My name is Mauro Serpelloni, and I'm Associate Professor in Electrical and Electronic Measurements with the Department of Information Engineering at the University of Brescia. My scientific activity concerns measuring instruments, sensors, and transducers for industrial and biomedical field. Since 2015, I'm in charge of managing Aerosol jet printing laboratory of the University of Brescia.
The Department of Information Engineering was established in conjunction with the foundation of the University of Brescia. Our department, through the years, has consolidated its role and image as a unique environment for conducting studies and research for information and communication technologies in a multidisciplinary and interdisciplinary way, including also fundamental research. The department's main competencies range in the following fields: automation, electromagnetic fields, electronics, physics of fundamental interaction, information technology, electric and electronics measurements, condensed matter physics, and telecommunication. Research activities are carried out within several research and development laboratories, and they are oriented to improve both fundamental and application-oriented research. Effort is also devoted to technology transfer to the manufacturing and service industry, wherever public or private. In this context, our department has signed a large number of contracts to conduct both fundamental and applied research, expert assessments, and exploratory development supported by private companies and/or national, European, and international funding agencies. In this context, after a comparative analysis of the various technologies started in 2014, we decided to open an aerosol jet printing laboratory. In 2017, we purchased an AJ300 commercialized by Optomec, a leader in this technology. This system is the only one in Italy. The Optomec Aerosol Jet 300 series printing system uses an innovative aerodynamic focusing system to deposit fluid and nanomaterial formulations on two-dimensional and three-dimensional surfaces. This allows to achieve higher performance than traditional inkjet printing or screen printing processes. Let's see in more detail how this technology works. We can see the cup that is used for storage of the ink. Liquid ink's viscosities between 0.5 and 1000 centipoints are typically employed. The aerosol jet printing is a four-step process: atomization of the ink, densification of the generated aerosol, focusing of the aerosol jet, deposition of the droplets into a substrate. First, an aerosol is obtained from an ink or dispersion by a pneumatic atomizer, which develops a dilute flow. Nitrogen or compressed dry air are employed as carrier gas. The only requirement is on the dynamic viscosity of the ink from about 1 to 1000 centipoints, which is more or less between water and honey. In a virtual impactor, superfluous carrier gas is removed and the droplet size distribution is adjusted in order to densify the aerosol, increasing the volume fraction of the aerosol droplet flow. The droplet size exiting the printing nozzle of a typical setup is smaller than 5 micrometers in diameter. Finally, the aerosol is focused in the print head. In this head, the aerosol flow is injected into a transition region where the shelf gas enwraps cylindrically the aerosol flow. These two elements are strongly accelerated when entering the print nozzle, which is a narrow channel with slowly decreasing cross-section. In a proper designed system, the gas flow is laminar and axially symmetric, with a small Stokes number for the particles in the transition region, becoming large at the exit of the print nozzle. The shelf gas prevents impacting of the droplets or condensation of the solvents from the aerosol at the inner wall of the nozzle and guides the aerosol flow. This technology offers many advantages with respect to screen printing or inkjet. First, this technique permits printing droplets with diameter sizes from 1 to 5 micrometers. which offers uniform printing dispersion. Second, the substrate, which can be heated to evaporate the solvent, is usually placed about 2 to 5 mm below the nozzle exit, with the surface perpendicular to the jet. This feature allows printing over surface irregularities, contours, or corners. Furthermore, this technology permits to print materials with conductive material loading up to 80 weight%. This is a key advantage over other electronic printing technologies, since it offers higher conductivity in one pass. The Aerosol jet system supports a wide variety of materials, including nanoparticle inks and screen printing pastes, conductive polymers, insulators, adhesives, and even biological materials like cells. Our system AJ300 has interesting printing features, line width from 10 micrometers to 100 of micrometer per pass, single pass layer thickness from 100 nanometer to 10 micrometer, ability to print on substrates up to 300 millimeters per 300 millimeters, XY motion proportional accuracy down to ±6 micrometers, 300 millimeters XY automated control, and 50 millimeters Z-axis automated control. Motion repeatability ±1 micrometer for each axis, virtual alignment system, alignment cameras and lighting, enable registration of line over line with multiple passes. Computer control system of printing parameters in AutoCAD format, plate, vacuum, and heated. The University of Brescia has among its objectives research activities, technology transfer, and services in sectors characterized by small series with high technology and customization. This activity has already gathered the interest of several companies in different industrial fields, from automotive to aerospace.
We received from High-Tech Elettronica the request to test some drawings of electronic components designed for the space sector, and we could see the relevance of this test compared to the specification of the drawings, providing all the technical report necessary to assess the future use for industrial purposes of this technology. Our university has received from High-Tech Elettronica the request to be able to continue the testing phases until the company is equipped with its autonomous capacity to manage the aerosol jet machine, giving ample availability as part of cooperation agreement that our university signs with different subjects, all the necessary support and the transfer of the skills of our knowledge. The university is open to projects with companies, laboratories, research centers, other Italian and foreign universities. You are all invited to visit our laboratories to see yourself the possibilities offered by this technology. Thank you all and see you soon.